Hello students, welcome to my channel. Today I am going to discuss about classification of data structure. In the previous class I have explained about introduction to data structure. Data structure is nothing but, here data is nothing but raw fact and structure is nothing but representation of data. So totally data structure is a particular way of storing and organizing data in the memory of the computer so that these data can be easily retrieved and efficiently utilized in the future when required. So data structure is nothing but organizing the data in a proper format. So here the classification of data structures. Data structure is divided into two types. One is primitive data structure and another one is non-primitive data structure. So in primitive data structure, further classifications are integer, float, char, boolean. In non-primitive data structure, again divided into two types, linear data structure and non-linear data structure. In linear data structure, arrays, linked list, stack, queue. In non-linear data structure, trees and graphs. So let's discuss one by one. The first one is primitive data structure. So we all know what is data structure. The next one is primitive data structure. So the primitive data structure is nothing but consists of numbers and the characters that come in inbuilt into the programs. So primitive data structures are also known as inbuilt data structures. Okay, so these are inbuilt into the programs. These data structures can be manipulated or operated directly by machine level instructions. Okay, so the basic data types like integer, float, character and boolean come under the primitive data structure. Why? Because integer, float, character, boolean, all these are built-in data types. So that's why these are known as data structures. Why? Because by using these data structures, we can store the data in a proper format. Okay, so these are the examples. So the first, integer is represented with int keyword, float is with float keyword, and character is with char keyword, boolean is with boolean keyword. Okay, so these are keywords as well as data types. So age, salary, gender, pass are the variables. So here int is a primitive data structure. So primitive is nothing but inbuilt data structure. The value cannot be changed. Integer stores only integer value, whole values. Those are positive numbers as well as negative numbers. Okay. Float can store the numbers which contain decimal part. Okay, either positive numbers or negative numbers. And character is used to represent one single character within a single quotation. Boolean is used to store only two possible values. One is true and another one is false. Okay, so these are primitive data structures. The next one is non-primitive data structure. So non-primitive data structures are those derived from primitive data structures. These data structures cannot be manipulated or operated directly by the machine level instructions. So here by using non-primitive data structures, we can store homogeneous data as well as heterogeneous data. We can store either homogeneous or heterogeneous. Homogeneous means same data. For example, if you want to store student numbers, roll numbers, all student roll numbers contains numbers only. If you want to store student names, all names contain only characters. Okay, so that is homogeneous, similar data items. Here heterogeneous means different data items. For example, if you want to store the details of particular employee, so employee number, that means employee ID contain integers, employee name contain alphabets, I mean characters, and employee salary contain float, employee age contain integer. So different data types. Okay, so based on the structure and arrangement of data, we can divide these data structures into two categories. Okay, so in non-primitive data structures we can store any type of data. Okay, these are not inbuilt data structures. Here these are the two categories. One is linear data structure and another one is non-linear data structure. So in primitive data structures you can store only one value in one variable. But here in non-primitive data structure, you can store any number of values in one variable. Okay, so linear data structures. Let's see. The name itself indicates linear is nothing but sequence. The data is stored in a sequence format, one after another. The arrangement of data done linearly, where each element consists of the successor node, successor element, and predecessor element, except the first and last data elements. Okay, so here the examples are arrays, linked list, stack, queue. So these are the examples of linear data structures. So let's see one by one. These are the categories under linear data structure. The first one is arrays. So we all know, very familiar with arrays. Arrays are nothing but it is used to store collection of data elements in a collection of data elements of the same data type into a variable. So array is used to store collection of similar data elements. Instead of storing multiple values of the same data type in separate variables names, we could store all them together into a single variable. For example, I want to store 5 student numbers. Okay, so for that purpose, I am taking int a is equals to 10, int b is equals to 20, int c is equals to 30, int d is equals to 40, int e is equals to 50. So I took 5 variables and I am storing 5 values. So by using arrays, it is we can store all these values into a single variable. Okay, so instead of using 5 variables, we can use only one variable to store all 5 values. That means a is equals to 10, 20, 30, 40, 50. We can store all these values into a single variable. If you observe, these are similar data items. All these comes under integer data type. So array is used to store only similar data items. Here these are all known as array elements and these are known as array indexes. Okay, so index always starts with 0 and ends with size minus 1. So if you observe 1, 2, 3, 4, 5, 6. So 6 is the size. 6 minus 1, 5. So starts with 0, ends with size minus 1. So array can be classified into different types. These three different types, one is one-dimensional array, two-dimensional array, and multi-dimensional array. So one-dimensional array is nothing but the array which contain only one subscript is known as one-dimensional array. It is stored in ascending storage locations. Okay, two-dimensional array is nothing but it contains two subscripts, which means it can store rows and columns. Okay, so multiple rows and columns of data elements is known as two-dimensional array. So nothing but matrix. Multi-dimensional array, the array which contain more than two subscripts. We can say that type of array is known as multi-dimensional array. So it contain may include many indexes are per the need, as per the need. So here as per the need. So array is completed. The next one is linked list. Linked list is another type of linear data structure. So here also the elements are stored in a sequence format. The data elements in these data structures are represented with nodes. That node contain two parts. So this is the node. The node contain two parts. One is data part and the another one is next part. The data part is used to store the data and the next part is used to store next node address. For example, this node address is 100, this node address is 200, 300 and 400. So head is used to store the first node address. So head contain 100 and this node contain data A and here it contain 200. Why? Because B is located at 200 location. Okay. So next C, here it contain 300, 400, Here next node is not available, so that's why here it will store null. Okay, in this way the data is stored in a sequence format. So each node contains two fields. The information field, that means data field, consists of actual data, and the pointer field, this is pointer field, it contains the address of subsequent nodes, next node. Okay, so linked list also classified into different types. One is single linked list, doubly linked list, circular linked list. I will discuss all these types in the next videos. Okay, so I will explain only introduction in this class. A single linked list is the most common, so we can say this is known as single linked list. Okay, so where it contain two parts, one is data part and another one is next part, that is known as single linked list. Okay, doubly linked list is nothing but it contain three fields. Okay, so here it contain three fields and two pointer fields and one information field, that means data field. So the data field contains data. The first pointer field contains the address of previous node, and the another pointer field contains the reference of the next node. So here it contains previous node address as well as next node address, so that we can traverse backward as well as forward. Okay, so the next one is circular linked list. So in doubly linked list, the first node previous address field is null and last node next address is null. Okay, but in circular linked list, the first node previous address contain the last node address, and the last node next field contain the first node address. So it contain like this circular linked list. Okay, the circular linked list is similar to single linked list. So if you observe, it contain one more part. So this is one more part, that means another pointer field. Assume this is the last node, so this last node contain the address of first node, so it becomes like this. Yes. Yes, let me do. Yes. Okay. This node contain the address of next node. Okay. So here the previous one contains the address of this node. Okay. So that's why it will be like this circular linked list. Okay. So I will explain all single linked list, circular linked list in the coming videos. Just remember these points. Okay, the next one is stacks. So stack is also linear data structure. It follows LIFO. LIFO is nothing but last in first out principle. So here the insertions and deletions are done at one end. Third end is known as top. All insertions means adding elements as well as deleting elements done at only one end, that end is known as top. We can say the real life examples, pile of books. So if you want a top book, okay, we first or else if you want the fifth book from the top, we can remove four books from the top and we will take the fifth book, right? So last in, whatever the last book, that will be removed first. Last in first out. And the deck of cards, pile of money, and many more. So this is the example of stack. So here this is the first element, this is the second, third element, fourth element. So first element is inserted first, next, third, fourth. So whatever the last element, that will be removed first. Okay, so we are insertion is known as push and deletion is known as pop. Okay, so insertions and deletions done at only one end, that end is known as top, last in first out. So the primary operations in the stack are as follows: one is push and one is pop. Push is nothing but operations to insert a new element into the stack, and pop is nothing but remove or delete elements from the stack. Okay, so the next one is queue. Queue is not similar to stack only, but insertions are done at one end and deletions are done at another end. Okay, so insertions one end and deletions one more end, but in stack insertions and deletions are both done at one end. That end is known as top. So here it will follow FIFO, first in first out. Whatever the element inserted at first, that element will be removed first. So some real life examples are line at the ticket counter. So the first person will get the ticket first. So first in, first out. An escalator, a car wash, and many more. So these are the examples. So this is the diagrammatic representation of queue. So here it also contains two operations, one NQ, DQ. NQ is nothing but insertions, DQ is nothing but deletions. Insertions are done at one end and deletions are done at another end. So the first element is inserted to, that element will be deleted first. First element, second element, third element, you can insert at this end and you can delete at this end. First in, first out. Okay. Next one is non-linear data structure. So in linear data structure, the elements are stored in a sequential format. But here, not in sequential format, not arranged in sequential order. Here, the insertions and removal of data are not feasible in a linear manner. There exists a hierarchical relationship of the individual data elements. So there are two types of non-linear data structures. One is tree and another one is graph. So the data in tree stored in a hierarchical containing a collection of nodes such that each node of the tree stores a value and a list of reference nodes means child nodes. So the tree starts from the root node. The root node contains many another nodes, many nodes. It contains a central node. That node is known as root node. Structural nodes and subnodes connected via edges. We can also say the tree data structure consists of roots, branches, and leaves connected. So this is the tree data structure. So here first it contains root. Next, the root contain children's. So this is B and this is C. So here B is a parent for this D, E, and H is a child of D and I is a child of E. So we can say D, E are known as siblings. Okay. So this is the root node and we can say this as key also. So all these nodes are connected by using edges. So this is known as level 0. Remember that levels are always starts with 0 and height always starts with 1. Okay. So I will discuss these graph topic in the coming videos clearly. Okay. Mm. So B is a parent node of D and F. We can say D, E are siblings and E is a child of B and B becomes the parent. And this is known as left subtree and this is known as a right subtree. And the nodes which does not contain any child nodes are known as leaf nodes. Okay. The next one is graph. Graph is an example of non-linear data structure. Why? Because the data is not stored in a sequential format. The graphs are utilized to address problems of real world in which denote the problem area as a network such as social network, circuit network and telephone networks. Simply we can say graph is a collection of vertices and edges. So graph is a collection of vertices and edges. V is represented vertices, edges represented with E. So this is the graph representation. Here A, B, C, D, E, F, G are known as vertices and these lines are known as edges. Okay. So the above figure represents a graph having several vertices. Those vertices are A to G and 10 edges. So A to B is one edge. Okay, one edge is there and A to C is one edge there. B to C is one edge is there. Next B to D, yes, B to E, C to D, and D to E, D to F, and E to F, and F to, sorry, E to G. So these are known as edges, and these are called vertices. So graph is a collection of vertices and edges. Okay, so these are the classification of data structure. So I hope it is clear. If you have any doubts regarding to this video, please comment me in the comment section. For more videos, please do subscribe my channel. Thank you.